I'm going to show you the coolest thing in this video. Let's just say that f of t is equal to e to the 4t. But what if I told you that you had to solve the Laplace transform of this? So we take the Laplace transform of both sides. F of t is equal to the Laplace transform of e to the 4t. And this is just for fun, by the way. This isn't actually something that's pretty common. What if I told you that you had to take the Laplace transform of e to the 4t without using the table? And you might have a few ideas on how you would do that, but I'm going to show you one method that works. That's really cool, by the way. So I'm going to choose an arbitrary denotation. I'm going to say that e to the... I want to prove the Laplace transform of e to the 4t. That's the goal, right? Because I want to prove this without using the table. The way it works is using the derivative formulas for Laplace transforms. So I don't know if you remember, but the Laplace transform of f dash is just going to be equal to sfs minus f of 0. I don't know if you've seen my Laplace transform of solve differential equations videos, or the one or two videos I actually have on it, or any other videos of anyone, or you've learnt it in class. You would have recognized this formula, right? Now, that's actually a big hint on how you can solve these. So what I do is I take this e to the 4t, and I'm going to say that that's equal to h of t. So now, I'm going to take the derivative of that, h dash of t, and that's 4 e to the 4t. Alright, I want to take the Laplace transform of both sides. See how I have a derivative here? That's exactly what I'm about to do. I'm going to apply the Laplace transform formula. So I'm going to rewrite it the other way around. So I'm going to have s hs minus h of 0, which I haven't found out yet, but it's the easiest thing to prove, is equal to the Laplace transform of 4e to the 4t. But I'm still trying to prove the Laplace transform of just e to the 4t. Okay, what's h of 0? If I plug in 0, h of 0 is equal to e to the 4 times 0. That's just equal to e to the 0. It's equal to 1, right? As anything to the power of 0 is 1. I don't know why I proved that on video, but it doesn't matter. So SHS, I'm going to rewrite it one more time. So SHS minus 1 is equal to... Now I'm going to bring this 4 out the front, because this is just an integral, right? Remember, Laplace transforms are just integrals. You can take this 4 out the front. So that's 4 times the Laplace transform of e to the 4t, because that's what we want. And look at this here. Just have a look at this. This e to the 4t is equals to h of t. If I just took the Laplace transforms of both sides right now, I'll do it over here. If I literally did that right now, so I have the Laplace transform of h of t is equal to the Laplace transform of e to the 4t. And remember, I can't say that this is 1 over s minus 4 yet, because I have to prove that. Well, I have hs is equal to the Laplace transform of e to the 4t. Okay, that means that this is just hs, because I've proved that here. So I can just call this thing hs. Now, I'm going to do another arrow, shs minus 1 is equal to 4hs. Now I'm going to take the 1 across by adding 1 to both sides, and I'm going to subtract 4hs from both sides, because I want to solve for hs. So s minus 4 is equal to 1. And I'm sure that the bells are ringing in your head right now. You think, far out, it's actually working. And it is. That means hs is equal to 1 over s minus 4. And there you have it. I literally just proved the Laplace transform of e to the 4t using the derivative formula without using the table. So, just to recap, all I did was take the function that I'm trying to prove. I made a note, I want to prove this. And I wrote down the relevant formula. I have e to the 4t. I set it to an arbitrary denotation. Then I take the derivative of both sides and I solve for the initial condition h of 0, because I can't apply this formula because I need to know what f of 0 is. So I have h of 0 is equal to 1. And then after I do that, I make the realization that in my original denotation, like this is just like a look, yeah? So I realized that, hey, this 4e to the 4t, I wanted e to the 4t, and 4 can come out the front because that's just how it works. That's a rule of the Laplace transform. And I realized that if I just took the Laplace transform of both sides of the original denotation that I made, I have hs is equal to the Laplace transform of the thing I'm trying to prove. That means that hs is equal to this. This is just a substitution, right? And then I substituted hs instead in place of the Laplace transform of e to the 4t. I do a bit of algebra and solve for hs, and hs turns out to be 1 over s minus 4, which means that therefore f of t is just equal to hs. Fs is equal to hs if you wanted to finish off the problem properly, and therefore Fs is just equal to 1 over s minus 4. So in future videos, I'm going to do obviously way more complicated examples, but this is fun. I don't know if you don't find that fascinating, but I think it's so cool that you're able to prove a Laplace transform without using the definition, but using the derivatives instead. That's pretty cool. That's like really cool. Anyway, thanks for watching.